We're going to work on outcome SS 9.1 on circles. But before we get into the unit, we want to do a quick review of Pythagoras' theorem. In any right triangle, the sum of the squares of the two shorter sides is equal to the square of the longer sides. If you know the length of two sides of a right triangle, you can use this formula to calculate the length of the third side. So let's do a couple of examples. Okay, so I know the length of one leg is 7, the length of the other leg is 10, and I'm looking for the hypotenuse. So on a right triangle, the side opposite the right angle is the hypotenuse, and the hypotenuse is always the longest side. Now, in your formula, a squared plus b squared equals c squared, c is always the hypotenuse. A and b are the two legs, and it doesn't matter which number goes into which leg. So we're going to substitute c, leave it as c, and then a is 7 squared plus 10 squared. Well, 7 squared means 7 times 7, which is 49, plus 10 times 10, which is 100, equals c squared. Okay, so c squared equals 149. Now we need to undo the squaring, and so we have to do the opposite. So the opposite, for example, of multiplying is dividing. The opposite of adding is subtracting. Well, in the squaring, the opposite of squaring is square root. So if we take the square root of both sides, we will have c equals the square root of 149, which is approximately 12.2. So a little dot above an equal sign means approximately. So we now have the side of the hypotenuse. We can go back and look to make sure it is the longest side. It is. And so we're pretty confident with our answer. Here, in the second example, we have the hypotenuse, which is 11.1. So we write down our formula, a squared plus b squared equals c squared, and we plug in the numbers we do know. So I always put in the number into the hypotenuse first. That way I don't get mixed up. 5.2 can go in for a, make sure you're squaring it, plus b squared. So if we're looking for one of the legs, we do one extra step. So 5.2 is 27.04. 5.2 squared plus b squared equals 11.1 squared is 123.21. So to solve this equation, I need to get the 27 to the other side. So I'm going to solve this as an equation. It's a positive 27, so to subtract 27, it will become a 0. And I'm left with b on the left side, and I'm left with 96.717 on the right. So b squared equals 96.17. We need to take the square root of both sides to find out that b equals approximately 9.8. So there are some examples here to practice, because we will be using Pythagoras' theorem a lot with the circles. And so you have to be confident with Pythagoras' theorem. Okay? I'm just going to jot down the answers so you can double check to see that you're doing them correctly. So I'd like you to pause the video and practice these Pythagorean theorem questions. Okay, we're going to talk about the properties of a line tangent to a circle. So all the things we're going to do in this outcome have to do with circles and finding the lengths of different sides of triangles within a circle. Okay, so if you have a line and it's crossing the circle, it crosses and hits at 2 points. If I move this line, it's going to cross and hit at these 2 points. If I keep moving this line, it will still cross at 2 points until it hits right on the edge of the circle. And when it's right on the edge of the circle and hits 1 point, we say that this line is tangent to the circle. Okay? There are some properties we're going to learn about the line that's tangent to the circle. So as the line segment leaves the circle, it intersects at only 1 point. So it's only touching the circle once, and then we say the line is tangent to the circle. Okay, a line that intersects a circle at only one point is a tangent to that circle. Line AB, in this example, is tangent to the circle with center O. The point where the tangent intersects the circle is called the point of tangency. So this little point at P is called the point of tangency. This line AB is tangent to the circle. So we're going to learn some rules about the point of tangency and the tangent line today. If you take a line and draw a line from the center of the circle to the point of tangency, you will create a 90-degree angle. So if you draw a line from the center of the circle out to the point of tangency, so where the tangent line touches, you will create a 90-degree angle. All right, so point O is the center of the circle. AB is tangent to the circle. So if you need to extend that line to make it look a little easier for you, you can do that, but that's saying that the line AB is tangent to the circle. That makes point A the point of tangency. Okay? So if triangle OAB, so triangle OAB, in this triangle OAB, angle OB, so this angle AOB right here is 63 degrees. What is the measure of this angle OBA? So when we're reading these, the letter in the middle is the vertex, or the point at which the angle curves, turns. Okay? So you have three letters to describe an angle. You go from the first letter O to the second letter B to the third letter A. That angle is OBA, and we're looking for that angle. Now, we know that angle A is a 90-degree angle from our rule on this page. The line that goes, the radius that goes from the center to the point of tangency will create a 90-degree angle. So we know we have a 90-degree angle here. We know we have 63 here. Well, a complete triangle is 180 degrees. So a triangle minus the 90-degree angle minus the 63-degree angle will equal angle OBA. Okay? So when we subtract those, we find out that we have 27 degrees left. Okay, point O is the center of the circle, and CD is tangent to the circle. CD is 15, OD is 20. So when we're talking about a line segment, we use two letters. So an angle uses 3, and a line uses 2. So CD is 15, OD is 20. Determine the length of the radius, OC. So we want to know this side. Okay, so we're going to put a variable there, x, and it says to the nearest tenth, so 1 decimal place. I know from my rule that I have a right angle here. Because C is the point of tangency, this line will create a 90-degree angle. If I know I have a 90-degree angle and a right triangle, then I can use Pythagorean theorem. It only works in triangles that have a 90-degree angle. Okay, so across from the right angle is the hypotenuse. So 20 is going to go in for C, 15 goes in for A, and B is going to be our variable. Okay, so we're going to square 15. It's 225 plus B squared equals 400. We need to subtract 225 to get it to the other side. B squared equals 175. I want to know what B equals, so I need to take the square root. And B is approximately 13.23. Now it's asked us to leave it to the nearest tenth, so the radius OC is about 13.2 centimeters long. Okay, so remember, we have to have a right triangle in order to use Pythagoras' theorem. All right, so we're going to use this rule with a word problem. An airplane A is cruising at an altitude of 9,000 meters. A cross-section of Earth is a circle with a radius of approximately 6,400 kilometers. A passenger wonders how far she is from point H on the horizon she sees outside her window. Okay, so here's the airplane. And the airplane is in the air about 9,000 meters above the ground. From the ground to the center of the Earth is 6,400 kilometers. Okay, so we want to know how far the airplane is from point H. Calculate the distance to the nearest kilometer. All right, so we can actually create, if we add another line in here, a right triangle. This point H is a point of tangency. It creates a 90-degree angle, so we do have a right triangle. We're going to redraw it and relabel it, okay, just to make sure we have all the dimensions. So this side, which would be the hypotenuse, okay, is the whole length is 6,400 kilometers plus 9,000 meters. Now we have to be very careful because they're in different units. So we're going to change this to kilometers. So it's actually 9,000 meters is 9 kilometers. So this length is 6,409 kilometers. We're looking for this side, but we need to have two sides. Well, from this point to this point, which is the radius, is 6,400 kilometers. From H to the center is also the radius. So it's 6,400 kilometers. So we have a right triangle, a squared plus b squared equals c squared. These numbers are going to get fairly large because we have a big number of 6,400 kilometers and we're squaring it. Okay, so what we can actually do, so we don't write down, there's two ways to do it. We could square them, but we could actually move this first. Okay, so b squared equals 6409 squared minus 6400 squared. That should be a squared. Okay. Now, I will have to do that on my calculator. The answer is not going to be 9. You actually have to square them and then subtract them. But if they're all on the same side, then you can do that in one step. So let's do that in one step. So 6,409 squared is 41075,281 minus 6,400 squared is 609,600,00. We have to subtract those. Which should be 115,281. And hopefully I've done the math right. And the square root of that number is going to be B is 229.5. So the passenger is about 340 kilometers from the horizon. Okay, so you're going to go on to do practice 1 for outcome SS9.1a.